Today we are going to be jumping into surface area and volume. A lot of this is stuff that you guys have actually seen before or done before. We're just going to make it a little bit more challenging by adding in some word problems. So the first page of your notes is going to deal with volume. So on each of these we're just going to match which shape it goes with. So a prism is normally going to look like a box. You don't have to draw these out. These are just if you don't remember your 3D shapes or anything like that. So you have a prism. A cylinder is like a can. A cone is just like an ice cream cone. A sphere is just a 3D circle. And a pyramid, we're going to deal with pyramids the least, but those just look like what you would see in Egypt. So I'm sorry if my drawings are terrible here. I'm not the best at drawing 3D shapes, especially in a small place. But we have prisms, cylinders, cones, spheres, and pyramids that we can work with. I'm going to leave this top section for you guys to try out on your own. The big thing that I want to highlight is what each of these variables means. So V stands for volume. That's why we have a V on each one. L is length. W is width. H is height. And R, whenever we see that, stands for our radius. Whenever we work with problems like B, C, and D, each of these you've been given a diameter, so you're going to have to take this. Our diameter is 18, so our radius would be 9. So remember, anytime you're given a diameter, you have to divide by 2 so you can get your radius. So pay attention to if you're given the diameter or radius anytime that you work a problem out like this. We're going to cover a couple of the word problems at the bottom of this. Anytime you guys work with things like this, you're normally going to be given your formulas. The only time you really won't be given a formula is if you're working with the volume of a prism, because most people can remember length times width times height. So, we're going to look at these two problems at the bottom, and this is where we take things sort of kind of a step above where you may have taken them before. And we're going to be using volume to compare two different shapes. So, you buy two cylindrical candles with different dimensions. So we have two candles. It's like you went to Yankee Candle at the mall since everything's open now. Or you went to Bath & Body Works, wherever you like to get your candles. There we go. Candle A has a diameter of 4 and a height of 8. Candle B has a diameter of 6 and a height of 5. And we want to know which candle has more wax. So what that means is we're going to have to find the volume for A and B. The first thing that we're going to do is we're going to take our diameter and we're going to change that over into a radius. So for candle A, since our diameter is 4, our radius would be 2. And for candle B, since our diameter is 6, our radius would be 3. We're going to use our cylinder formula. So the volume of a cylinder is pi r squared h. Like I said, you don't have to memorize these formulas. So for A, our volume, pi doesn't change. Our radius is 2, and we square the radius, and then we multiply by our height. And I just put each of the things that I plug in parentheses. That's just something I always do. From there, I'm just going to type that into my calculator. So to get pi, we press second and then the little up arrow. So pi 2 squared times 8. So our volume for candle A is going to be 100.5. Now we need to find the area for candle, or the volume for candle B. So our volume, we're going to find it using the formula pi 3 squared times 5. I'm just going to pull my calculator back over and we're going to type that in. So pi 3 squared times 5. And that gives me a volume of 141.4. So in this case, candle B contains more wax because it has a bigger volume, so we can put more inside of it. Next, when we look at F, this is actually going to tie together not only what we are doing in this piece, but it's going to tie in what we have as our next set of notes, which is density. So if one guppy requires 5 liters of water to live happily, what is the maximum number of guppies that should be kept in this aquarium? Anytime you're given something in parentheses at the end where it has one unit of measure compared to another, that means you're probably going to have to make a conversion at some point. The first thing that we're going to do is we're going to find the volume of our aquarium. Because this is a rectangular prism, we're going to do length times width times height. In this case, you can make length, width, and height whatever you like. So that's the nice thing about prisms. You can just pick whatever you want to do. Normally, I do my width, my length, and my height. So height is however big it is from the ground to the top. Width, I always think about wide as going back this way. And then length is how long it is looking head on. But you can label it any way you like. So our volume would be 40 times 30 times 30, which when I type that into my calculator gives me 36,000. Now, we were told that one guppy requires 5 liters of water to live happily. And this right here is in cubic centimeters. So to go from centimeters to liters, we're going to have to divide by 1,000. So there's 1,000 cubic centimeters in 1 liter. So we're going to do 36,000 divided by 1,000 centimeters cubed. And that tells us that we have 36 liters. To find out how many guppies we can put in there, we're going to divide our number of liters by 5, which is going to give us 7.2. Now we can't have 0.2 guppies living inside of there, so we're able to have 7 guppies. Check out our next video to learn a little bit more about how we're going to use surface area. In this video, we're going to be spending some time talking about surface area. So with surface area, the main things that we're going to talk about are prisms, cylinders, cones, and spheres. Now, whenever we work with these, sometimes we don't want to just jump at the first formula that we see. We want to look at each of our shapes and decide what's going to be the best strategy to use to help us solve these problems. So we're going to go over just a couple of these problems together. Anything we don't do on this page, I want you to do on your own. We're going to look at problems 1 and 4 together. On number 3 and 4, I want you guys to remember, use your diameter to find your radius. So anytime you're given a diameter, switch it on over to radius. Now, most of these variables follow the same thing that we learned about on the first page of these. But cone is going to be a little special, and that's why we're going to go through number 4 together. When we look at number 1, this is a type of prism. It's actually called a triangular prism. But this prism and that formula are not actually going to go together. And the reason for that is we have a bunch of different sides going on, and by making it a triangular prism, it changes the way that we need to find our surface area. With a problem like this, we need to take into account each of the individual pieces that we have. So the first thing that you guys should notice is we have 2 triangles. So I have a triangle here and a triangle over here. These triangles are the same size. So we're going to find the area of one triangle and we'll multiply it by 2. That way we have the area of both. So to find the area of a triangle, so area is going to be 1/2 base times height for a triangle. Our base down here at the bottom is 4. So 1/2 times 4, and our height is 3. This is a formula that you guys should know from previous classes. That's not one that I'm going to give to you. You should know how to find the area of a triangle on your own. And so that's going to equal 1/2 times 4 is 2. 2 times 3 is 6. Since we have 2 triangles, we're going to multiply that 2 by 6. So 6 times 2, or multiply that 6 by 2. That gives us 12. So our triangles, that's 12 units. The next thing that we're going to look at is each of the faces that we have left. So down here at the bottom, we have a rectangle. This rectangle is 4 by 8. So to find the area of this bottom rectangle, 4 times 8 is 32. So I'm going to add 32 to my 12. Next, we're going to look at our rectangle that makes up the back over there. So even though this side isn't labeled, since we know that this is a rectangle, we know that this side is also 8. Since we have 3 by 8, Three times 8 tells us that this rectangle in the back is 24. Oops, sorry. The last piece we have here is we have a square around the top. Let me find a highlighter. There we go. So this is our top face. So the slanted piece that's on the top. Whenever we do that piece, it is 8 by 5. So 5 times 8 is 40. So we're going to add 40. So that means our surface area for this entire shape is going to be 12, because that represents the 2 triangles, plus 32, plus 24, plus 40, because I have 1, 2, 3 faces. And that is going to end up being 4. My brain is not ready to do mental math today. I'm going to type it into my calculator. 108. And these little dotted line, or these 2 parentheses, that means inches. So 108 square inches. When we see one like number 2, that's where you're going to be able to use your prism formula to help you. And remember, when we do a problem like number 2, you just decide which one is your length, width, and height. So I would do height, length, and width there. Match your shape to your formula to help you figure out which one you need. Now, we're going to look at our cone, which goes with number 4. The surface area formula for a cone is pi r squared plus pi r L. And here, L is the slant height. L takes on a new meaning in this, and this sort of kind of helps us figure out the length that it's going up on the edge there. So this is very different from our volume formula, and it takes a little bit more effort to solve. Whenever we work on a cone where we're doing surface area, you use slant height. Volume, you use the normal height. A lot of times you'll be given the height and the radius or the diameter. Whenever we're dealing with this and we need to find the slant height to do the surface area, we're going to have to use our Pythagorean theorem, because inside of each cone is a cute little triangle, and it's a right triangle, and we're able to use a squared plus b squared equals c squared to help us find our slant height. We're looking for our hypotenuse, so we'll do 5 squared plus 8 squared equals c squared. I'm typing 5 squared plus 8 squared into my calculator, and that gives me 89 equals c squared. To get my slant height all by itself, I take the square root. So our c, which is our slant height, is going to be the square root of 89, or 9.4. Now that we have our slant height, we're able to plug this into our formula and solve to get our surface area. Pi stays pi. Our radius is 5, and we know that this is a radius because it goes from the middle to the edge. Remember, a diameter goes from one side to the other, a radius goes from the middle to the edge. And we always want to use a radius in our formula. So pi times 5 squared plus pi times 5 times 9.4. And I'm just going to type that into my calculator exactly the way I wrote it out. Pi times 5 squared plus pi times 5 times 9.4. And that's going to give us surface area equals 226.2, and because this is inches, inches squared. Anytime you work with surface area, you're going to use units squared. Anytime you work in volume, you're going to use units cubed because it takes on another dimension. One thing that I want you guys to know about with cones, cylinders, and spheres is a lot of times you may not see your surface area or volume written out in a decimal form. Sometimes you may see it in terms of pi, where it'll be like 34 pi. Anytime that you're working a multiple choice question and the answers look different to the way that you have yours written out, you can always type them into your calculator to see which answer will give you your decimal that you were able to find. We're going to go through one more page of this in our next video where we do some more word problems, but go ahead and try out the other 3 problems on this page on your own. The last part of our surface area and volume notes that we're going to go over today is working with volume and surface area formulas. While you may have found the volume and surface area of an object before, we're going to take things one step further and help you guys find out how to solve for each individual piece of the formula or solve for a variable using the information that you know. These are going to be a little bit more challenging and require a little bit more problem solving skills. The first thing that we're going to do is we're going to look at number 1. The volume of a sphere is 523.6 inches. Determine the radius, justifying each step algebraically. The first thing that I want you guys to do anytime you read the word volume or area is write down the formula that goes with it. So the volume of a sphere is calculated by V equals 4 pi r cubed over 3. We know that this volume is equal to 523.6. But that's all the information that we've been given. So 523.6 equals 4 pi r cubed divided by 3. And it wants us to solve for the radius. The radius is the only thing that we don't know here, so it's going to be pretty easy to solve for. All we did was plug in the information that we knew, and now we're going to solve for the variable it's asking for. So to get our r by itself, the first thing that we need to do is we need to get rid of the 3 because it's the furthest thing away from our r. So I'm going to multiply each side by 3 because this is dividing by 3, so to undo division, we'll do multiplication. 523.6 times 3 is 1,570.8 equals 4 pi r cubed. From there, we need to get rid of the 4 pi. Now, you are allowed to get rid of the 4 and the pi at the same time, but we have to put it in parentheses when we divide. And the reason for that is if we don't put it in parentheses, it'll actually end up doing a weird order of operation things where it multiplies by pi. So, 1,570.8 divided by 4 pi in parentheses. And that's going to get rid of all of the 4 pi stuff. That leaves us with 125, and I'm just going to zoom over here. So 125 equals r cubed. From there, to undo the cube, we're going to take the cubic root. So remember, this is just like a square root, but instead of doing a normal square root, we do a cubic root. To do a cubic root in your calculator, you're going to press math, and it should be the 4th option. And that'll put a little 3 out in front of your root. So the cubic root of 125 is 5. And since our original unit was inches cubed, it would just be 5 inches. Before we move on to the next problem, I just want to show you guys that if you don't put those parentheses, it does change your answer. So if I did 1,570.8 divided by 4 pi, it gives me something completely different. And the reason for that is it doesn't realize that you're dividing by pi as well. So we have to use those parentheses anytime we divide by more than one thing. The next thing that we're going to do is look at number 2. The volume of a cone is 2,035.75 feet cubed. The radius of a cone is 9 feet. So we're going to stop right there, and we're going to write out the information we know. So the volume of a cone means we want to use this formula first. We know what the volume of that cone is. It's 2,035.75 feet cubed. And that's going to be equal to 1/3 pi. We've been told that the radius is 9 feet, so 9 squared times h, because we weren't told the height. What is the surface area of the cone? So right now, before we can get to surface area, we need to figure out what this height is, because that's a missing piece of information. To start off with, I see a 1/3. I don't like to deal with fractions, so anytime you want to get rid of a fraction, we're going to multiply each side by whatever the denominator is. So I'm going to multiply each side by 3. So 2,035.75 times 3 gives me 6,107.25 equals pi times 9 squared h. To get our h by itself, I'm going to divide by pi 9 squared. And remember, we're going to have to put that whole thing in parentheses in order to divide by it. I'm going to have to swoop up there. So to type that in my calculator, 6,107.25 divided by my first set of parentheses, pi 9 squared, and then close my parentheses out. And that gives me 23.999, which rounds up to 24. So my h is going to be equal to 24. Now we're talking about a cone here, so I'm just going to sketch this out because sometimes a picture is really helpful when we work with these problems. Our height is 24. The radius is 9. And it wants us to find the surface area of the cone. So what is the surface area of the cone? When we set up our surface area formula, we know pi, we know our radius is 9, so pi 9 squared plus pi times 9, and then we're missing L. Remember, L is our slant height. So in order to get our slant height, we're going to have to do our Pythagorean theorem, which is why we had to solve for our height. The only way that you can get your slant height is if you have the radius and the normal height. So 9 squared plus 24 squared equals our slant height squared. I'm going to type 9 squared plus 24 squared into my calculator, which gives me 657 equals L squared. I'm going to take the square root of each side. So that means our slant height is going to be 25.6. And I'm just going to plug that in to the end of my surface area formula. Now that I have my full surface area formula, I'm just going to type into my calculator the way it appears. So pi times 9 squared plus pi times 9 times 25.6. So our surface area here would be 978.3. Our units was feet, and since we're talking about surface area, we square the units. This is probably one of the toughest problems that we do, number 2, because you have to make the connection between the height and finding the slant height. Number 3, this is going to be a more advanced type of problem as well. The length of the base of a rectangular prism is given as x plus 4. So I'm going to write out length equals x plus 4. The width of the base is x plus 2. So width equals x plus 2. And the height is 3 more than twice the length. So height is 3 plus 2 times the length. Now we're going to have to take this height and we're going to have to figure out a different way to write it, because we can't just say it's 2 times the length. So we're going to rewrite this as h equals 3 plus 2 times our length was x plus 4. So we just replace the L with x plus 4. So to get our height, we'd have 3 plus our 2 goes to the x and the 4. So plus 2x plus 8. So that means our height is 2x plus 11. To build a function that represents the volume, our volume is length times width times height. All we would do here is write our factors out beside each other. So length is x plus 4, width is x plus 2, and our height would be 2x plus 11. So this takes some extra algebra skills, so it's a little bit challenging to find our height, but it's not too hard to figure out our equation from there. To give you guys a little bit of a challenge, I'd like for you guys to try out number 4. A tip here is you're going to have to start with your surface area and use that to help you find what your radius is to figure out what the volume is from there. So try out number 4 on your own. Let me know if you guys have questions. Like I said, these are advanced problems, not as much the ones that we're going to be working with. We'll see a couple of these every now and then, but be prepared for most of the stuff from our first 2 videos for your quiz.